Yeah, I was polishing them a bit. We can start when you're ready.
All right, so welcome everyone to the September 8th edition of the KubeVirt SIG storage meeting. We will jump right into the agenda. So go ahead, Alex.
Right, so we have the VM state feature in KubeVirt. I'm going to start with a bit of a overview of the current issues, and we plan to tackle them and not in this release, in 2 releases time. But we're kind of starting the R&D now. So right, so I'll start with the issues with that feature. First, we have a PVC per VM, and this increases the number of PVCs which are on some platforms or vendors. Just the sheer amount of volumes is limited. Um, I know this is the case with like a cloud, Amazon FSX, I think, is limited. Some aren't limited, but just having one limited is already an issue for us. So that's one issue, just limits. The other big one is minimum size limits for the PVC itself. Um, we only need about 20 megabyte, maybe it goes higher to 100 megabyte for new features that we're developing, but we're always going to end up wasting space. And to make things worse, some provisioners are simply not binding over small volumes. They just refuse to provision to provision those. Like they would not round up to the nearest allowed size. So it just doesn't work, and we have to kind of convince them to make adaptations, and in some cases they won't do it. So that's another issue. And those are the main ones. Maybe if somebody wants to add more. Um,
So I think there's even more for that second point, which is not only would the PVC like not bind, but if we work around that and choose their minimum size, then the wastage or the wasted storage goes way up. So like the example you give of 50 gigs is actually a real one. So and it's a cloud. So imagine paying a monthly cloud charge of 50 gigs extra unused storage per VM. Just in general, it really raises the cost of operating virtual machines on those platforms.
yeah, yeah, just wastage is real too, like for sure. So those are all real problems. I don't think there's getting away from introducing something on the KubeVirt side to make this easier. And that's what I'm going to discuss. And I think it's mostly between two options. Either we have KubeVirt manage this, or we have a CSI driver specifically for this backend state, and KubeVirt has to get bundled with this CSI driver. So in the Virt handler case and in KubeVirt's case, managing this PVC, I imagine it would be managing a storage pool in the form of one PVC per node, and that is then pooled. You just use subpaths or something like that, and just I guess, but I put in details and a question mark because as I thought about it, I was like, wait a minute, this is really similar to like the host path provision or driver implementation. But essentially, it would just bind mount for file system volumes, and if it's a block pool, then it has to put a file system on top, and then um, behind Kubernetes back, just bind mount those uh, those subpaths. So that's for KubeVirt managing a PVC per node. Again, I'm maybe missing something. I don't see a way to do it differently right now. It To me it ends up very similar to a driver, and
Mhm.
that connects to the second point, which is an already existing solution in the host path provisioner. Um, and that is already allowing you to specify one PVC as the pool, and then you can the host path provisioner basically does all that block volume management, putting a file system on top. It watches over it. It does more things. It's not just that. It's resilient, reacts to, I think it has a watch on nodes even, adding nodes, removing nodes from the cluster. So like it's already implemented there kind of, but it's like a general driver. So like how do we maybe we're missing like the really interesting stuff in it for the TPM use case, which is like the main one at the moment. So
Mhm. Yeah, I
uh
think, oh,
yeah, go
sorry.
ahead. Go ahead, go ahead.
So I think one of the big issues when I've thought a little more about the either of these cases is we have to remember that although a VM is only running on one node at any one given time, it can run on different nodes. So if you have um, if you have a VM that, for example, runs on node A and it may establish some TPM data then on the PVC associated with node A, if that VM, like for live migration, it's less of an issue because QMU is responsible for migrating the data to the other node, and this storage could be treated as non-shared storage. But if you power down the VM and then the next time you start it up, it wants to run on node B, you're going to find you don't have the TPM data or the VM state data associated with this VM on node B. So there would need to be some kind of provisioning step where KubeVirt would essentially figure out which uh, PVC has the data for that VM and replicate it to the node before it could start. So there'd be a bunch of management with that. And then I also get concerned about VM snapshots and backup use cases, for example, because then you have to, I mean, this is why this underscores the reason we've always used uh, single PVCs for logical storage, because then you can use standard Kubernetes APIs and scheduling primitives to ensure that the data is where it needs to be and gets handled properly with Kubernetes APIs. So I think with either of these, we're going to run into those kind of issues. HPP doesn't make a guarantee that, I mean, it's non-shared storage as well. So it really has the same problems. And additionally, there's no snapshot support for HPP. So you would have to come up with a way to do snapshots of this data in a way that would work. So I think those are both
I
very
don't
large issues.
I'll start with the last point since it's the freshest. I don't think we're blocked anymore over developing naive volume snapshots on HPP. I think they put in the distributed flag since I may be wrong, but we could do something there. That is, if we choose the HPP, we may just go a different direction.
Hmm.
Like, yeah. The first point, the we already allow this backend state PVC to be uh, rewrite once, and we kind of migrate it through, I think, similar to how you migrate the cloud init data. So over the network, what maybe I'm missing something, but that should just work.
But read write once means that it can be attached. Let me see. I'm trying to think about this. So yeah, someone help me out. But like if it's read write once, Um, yeah, what happens when we run? Have we really played around much with running like a VM state enabled VM on HPP, and when it gets rescheduled to a different node?
Yeah, it just creates a new PVC and storage migrates the data. Maybe I'm terribly wrong. It's
You are wrong.
Alexander. Oh,
Yeah, because for one, if you use HPP, once a VM is on a node, it cannot move, right? It's 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 stuck there due to the topology of HPP. Uh, but Adam's point was correct. If we have a read write once volume for every node, and we have a PVC that's read write once, and we don't put a topology on there, and we say, hey, I can start this VMO node. We need some mechanism to get the contents from where it was to where it's going. And if you do a live migration, then the live migration takes care of the copy. But if you stop the VM and then start the VM, then that doesn't happen.
all right. Yeah, yeah.
Yeah, so I think that we would have to like almost having it yeah, like you would almost, I would think, have a want to do something. If you were going to do a storage pool, you'd almost want one like master PVC that like is the vault that stores all of the TPM. And remember, like, so the things that go on VM state are the TPM device, and also we will also have the CBT bitmaps in the case of incremental backup. So you would almost need like a provisioning phase when a VM is booting, that you go grab the data, provision it to the PVC where the VM is going to run, and then once that stage is done, then the VM is able to start. Um, and you'd probably have to copy that over the network, like before you start the VM. So it's a little bit, and then for like for snapshotting, for exporting, like basically all the different operations that involve VM storage, we would need some logic to ensure that the VM state data is also captured or handled properly. So it's definitely harder than just saying this PVC is part of this VM, which is the nice clean separation that we currently have. Now, if you had the HPP approach, you get some additional nicety about that, because you could still have each VM associated with a PVC for VM state, that you would have no wastage, or like it's cheap to create HPP PVCs, so you could still have that API object in the system, but you would still need to implement snapshot support, and then you have to manage this idea of a layered storage class within KubeVirt. How big should the underlying PVC be? What happens if it fills up? And like other kinds of aspects around that. I don't know if that's simpler, but it probably means less invasion into the KubeVirt code, like various code flows, because they would still appear to the other bits of the code as a PVC. But I think in either case, it's adding a significant amount of complexity, which I don't know if we can avoid, but it would be nice if we could.
Yeah, so with HPP, I think it's becoming less relevant, but I do think we can somehow stay in the CSI driver realm, and since we know the use cases here, and we know this is like a driver specifically for this backend state um, implementation, then we can just tweak some, like play on the assumptions and, you know, achieve snapshots in this way.
Mm-hmm.
I'm not sure, to be honest.
I mean,
maybe there's
if we have a if we had a platform that provided us with read write many file system volumes, which I guess is rare, so maybe it's not even worth mentioning. I thought of the idea of you could just have one large read write many file system volume that's attached to every vert handler, the same PVC, and then each vert handler would have the same view into the VM state data and could arrange for it to be visible to a VM, but that's a pretty large single point of failure too, and also not available in every cluster.
the single point of failure issue has been like in the back of my mind when I wrote all of this. It made me see the positives in the current approach. Obviously, those are not going to last long because, you know, vendors don't give you big enough volumes, or you just waste the space, or
Mm-hmm.
limits, PVC amount limit. But really, it's at least we don't have the single point of failure issue. I imagine if you tell users that with this new architecture that it becomes a single point of failure, they would be looking at us to provide the protection as well.
Mm-hmm.
I don't know, like what do you use today in enterprise to mark some PVC as like special? Like you put it, like you start replicating it, or
Mm-hmm.
um yeah.
I think another approach, so you have the third option, um, and I don't know if I've thought about this one a little bit. I don't know if it's going to be full enough of a solution, but I had a thought that if you could serve the TPM data from a like a web server of some sort. I don't know exactly what this looks like, but the idea would be that you have a single server that KubeVirt deploys, which is like a VM state repository, and that would be attached to a large PVC that would be provisioned. And then when a VM starts, QMU could be told to retrieve its VM state from, like, it could be configured with a VM state server. And when QMU itself tries to start, it pulls the data down. And then it could also be like anytime it's meaning to flush the data back, it would flush it to via the server. Like that creates a different kind of failure point. Like what happens if the server goes down? You might need to have it, with multiple replicas or something so that it could be stable. But the idea would be then that QMU is doing network IO to persist VM state information, because I don't think it flushes it every time the guest writes, if I understand. Like it might cache that a little bit. I could be wrong, but it was something I was thinking about. Then if we had a network solution, you could potentially simplify the storage provisioning, because then you could actually just have one single large PVC for each KubeVirt installation that handled it for all KubeVirt VMs. The problem with this is, like, how would you handle the CVT bitmaps, for example? Like, I guess you could pull those down, and like it could maybe be taught to flush those as well, but that would just push a lot of complexity to QMU, which KubeVirt might like, but QMU might not like. And I'm not sure if it's the best technical approach either, but it was another option that I had considered.
Yeah, I put that in the doc.
Um, yeah, I think just to, I have a crazy idea, but just, yeah, I think the issue with that one would just be making sure everything is highly available would be hard.
Hmm.
Okay, here's my crazy idea. What if, right now we have one PVC volume is one disk, and that's nice. But what if we could have a new volume type where we could, it's a file system volume, we leave space for the TPM and stuff. So kind of use that. And then for a block volume, we would like partition it and put a file system on part of it for TPM and use the rest for the VM disk. So somehow chop up whatever volumes we get provisioned.
Hmm. Yeah, it's a super interesting idea. I get always scared of one of the, like, we have 3 tenants within the KubeVirt storage uh design like principles, which is we've always had the one disk per volume, but I think in any of these cases we're actually kind of breaking that down. But I think I spoke with Vivek um at a conference, and he suggested that idea. I know that libvirt allows you to uh when you're working with a block volume, I think you can use offsets and lengths to talk about like where in the volume the disk exists and where you can write to. I think that's a super interesting idea. And if you provision the root disk, like I've always said that it would make sense that the TPM storage is highly co-located with wherever the VM's root disk is, because then if that storage is having problems, like your VM is kind of toast anyway. So like you're either going to have file system corruption or you're going to have loss of VM state. So putting it together means that you're not spread across 2 failure domains. So in a way, I kind of like it um, for that.
I
I think
like
that
it.
would be,
Sorry, go ahead.
yeah, and I think it's something that we might be able to test now.
Yeah, I like it too. The block part came up before. I don't know if you remember. Um, it was with Roman over some other feature a long time ago. With KubeVirt putting a file system on top, there was some big issue. I can try to dig out the.
No, that was for when there was a PR to for us to basically for TPM to allow a read write many block device. So it's definitely a little different case.
Oh, right. Sorry. Yeah. Yeah. Cool.
Yeah,
Yeah.
they said that you could have multiple, yeah, separate nodes that mounted the same file system at the same time, and that it generally would work. But in this case, it would be, I don't know. Yeah, I guess we would have to try that to see if you created a file system on part of the block device, um, and then you attach that thing, like how would, I guess it would just be QEMU. Yeah, I don't know how we would be handling that file system. Also, could we just have, yeah, I don't know. We'd have to look at that. I thought that TPM gained block support, but we also need to be able to put the bitmaps there. So it does need to be a file system. But like who mounts that then, I guess, if you have that volume that's split and the first part is a file system, when you do, for example, a live migration, um, how does QEMU handle that when you start it on the other side? Because you still have to attach that volume on the other side. I guess we would treat it as a block device. If it was a block device, and then KubeVirt would have to figure out how to mount that, and I don't know how that would work. Maybe, yeah, I don't know how that
Yeah,
would
no,
work.
actually it has like all the same challenges as that other PR that they were doing. So, but
Mm.
yeah, maybe there's a workaround.
Yeah, just quickly going back to that read-write many file system. If we really wanted, we could kind of force it. So you could always do what Portworx does with NFS. So you just instead of using HPP like I initially wrote down, you could have your driver create an NFS server. It's very adventurous, but you would create an NFS server and serve up with that volume backing it, a giant volume backing it. Then you have read-write many file system storage.
Mm-hmm.
Yeah, I accidentally saw Alexander's hands raised. It doesn't give me any other feedback. Go ahead.
You have like, you still need to read write many like NFS server itself though.
Mm-hmm.
Go ahead,
Yeah, you could.
Alexander.
So, I've sort of been thinking about this a little bit, especially since I've actually been working on implementing snapshots for host path provisioners. And you know, that has some unique challenges, like how do I restore to another node and things like that, which has somewhat of the same challenges as we have here. And one of the things that I was thinking of is using a Copia repository as the place that I'm storing my snapshots. And then when I need to restore to a different node, I just grab it from the repository. So what would happen is, my volume is on whatever node it is, and stuff gets written there. And then when I snapshot it, it gets copied over to the Copia repository. And then when I restore it, it gets copied from the repository to whatever node I'm restoring to. I think that might work here as well. So we have one central repository that has, all the backing volumes. And then whenever we need a volume on a particular node, we can just grab the data from the repository using Copia.
Mm-hmm. Yep. Yeah, that would be nice to kind of use a standard. And I guess if you treated that Copia repository, then any flows that needed access to that data could use the Copia repository as the source of truth for it. Although if the VM is currently running, it might not be accurate. Like for export, for example, I'm thinking of like you would just connect it to the Copia repository potentially somehow.
Just for the single point of failure there is you can replicate the repository. So
I think that is interesting, and I'm actually thinking also more about Alex's like NFS overlay idea is something that's kind of interesting because we could probably like QEMU typically within KubeVirt, we're only connecting storage to files or block devices using PVCs, but QEMU can be told that a disk is directly on an NFS share. So if we really wanted to,
my
we
biggest problem in all of that type of stuff where we have the VM trying to directly connect to a network, whatever, is that there could be network policies that prevent a particular namespace from connecting to a server in another namespace.
Cause but I was wondering, would it,
into the storage layer, then we have all the network communication inside the namespace of the storage layer, and then we don't have that particular policy issue.
mhm. Yeah, that's a good point. I think it's also worth noting that, we don't necessarily have to replace if we want to, like, we don't have to replace what we currently have. We could add a new mode if we wanted to, and I know none of us love testing additional permutations of things, but like if we wanted to introduce a new method for VM state handling, we could actually do that and have it something that you could turn on. So if you're on a particular platform that really hates, and this could be done for a while, like if you're on a platform that does not like the current approach, because it works fine, I guess, for some kinds of storage, it works better than others. But if you're on a platform that's really bothered by the current way we do it, you could enable the new method, and we could carry both of them for a while and then see how it works, and maybe potentially over time deprecate the current approach. So it's not something that we'd have to make available to everyone. But yeah, we don't want to carry too many permutations of things because this touches a lot of areas.
Yeah, with Alexander's idea, how do you handle the stop start? I mean, the CSI clone volume snapshot, that's great. But how would it work for stop start? Are you implying that there's some way to do that as on
It's
stop start
basically
as well?
it basically you remove the topology restrictions from host path provision. Or we're saying host path provisioner, but we're not actually going to be using host path provisioner, right? It's just sort of or maybe we are, I don't know. But just the thought of how host path provisioner is structured right now, where we have the pools and stuff. The point I'm making here is that we can have a read write once volume that is attached to a particular node, and then during the attach phase of the CSI driver, we just grab the contents from the repository and copy it, to whatever volume we create on another node.
Okay.
And that way it's read write once that's not tied to a particular node. And from a perspective of the VM, it's transparent. It's just I'm attaching a volume and it got attached somewhere else, and we have to clean up and things of that nature. But the Copia repository is the one that has all the actual latest information.
Gotcha. And what's the Scopia requirement? Like, what are we asking the user to have? Like a cloud repository, like some bucket, or like what's the requirement for that backing thing?
There's many different types of Copia repositories that you can use. It could be a bucket, it could be on a volume, it could be whatever. There's lots of options.
Like it's software on top of the backing
Yeah.
storage.
Yeah, and it does encryption, and it does only change block transfer and things like that. It's very similar to well, now the name escapes me. Basically, OADP uses Copia at this point, so I forget what OADP used, or not OADP. What's the upcoming version of OADP? Valero. What does
Valero, yeah.
Valero use for their backing storage, or for their?
Okay, so I think there's a couple ways that you could do this, but it might be a hybrid approach. So if we look at the first mention, the first point, we have vert handler with a PVC per node. But that PVC would have multiple, so like I guess in that case, what you could do is when you're starting a VM on a particular node, KubeVirt could communicate with Copia to restore the VM state to the correct PVC as part of VM startup, and then as part of VM shutdown, it could actually back it up to the Copia repository. So that would be one way to do it. But if you had an overlay driver, such as HPP, you could actually augment the right at the CSI layer, that essentially the volume, something encoded in the volumes, is a key to data in a Copia repository, and as part of attach, it does an automatic restore from Copia, and as part of detach, it does an automatic save. So then it would actually hide the Copia logic behind the, like, within the CSI API, and you wouldn't even have to like know that's happening.
Right, exactly.
That could be interesting. But then you would still need that HPP, for example, to be built upon a set of like a PVC per node, wouldn't you? Because then you would use that, like today we have HPP can use an underlying PVC. So would you need an underlying PVC per node that you would then like I don't know. I'm trying to think of how that actually works. I guess not necessarily,
I
but the
think,
driver itself could figure that all out itself.
yeah, I think it would be a little ugly to try to put this on top of existing HPP. I heard it in, I believe, in Alexander's voice too. But like the
Mhm.
idea would be similar.
Mhm.
Just you extend it in that direction with the repository.
I think the key though is that you wouldn't want to, for example, expand this into an ephemeral style volume, because we need to handle the case where like if something goes wrong, the VM state data needs to be written to some storage that's persistent somewhere. And then if something bad happens, it should be somewhere, and you should be able to, well, I guess it's in the Copia, but like, let's say a VM is running and it crashes, and for some reason we're not able to properly detach the PVC, so we don't actually write the data back to Copia. Can we tolerate the potential data loss that would happen?
I would say no, but that's why we need some persistence on a particular node.
And so would that be, I guess it could be if it's, yeah, I don't know if it's one, like what is the granularity of those PVCs? Is it one PVC per node? Okay. And it's just attached, it's basically that PVC is attached to all VMs that are running on that node.
Correct.
Yeah, I
That's an
think,
interesting idea.
yeah, I think I'm going to highlight the copy idea and one PVC, one disk challenge for now. And I think we have a lot of people.
I have one question for the one PVC, one disk. What about VMs with multiple disks? How do we decide which disk is the one that holds the backing storage? Just the first one or something?
Like in general, it would be the boot disk, but I think the idea from Michael was that you have a dedicated volume type. That's a new volume type. And if you want to use TPM, you have to have at least one disk defined in your VM that uses the whatever the multiplexed volume type or something like that.
Gotcha.
And maybe you'd expand that disk in the API to specifically say that there's a TPM here.
Yeah, that makes sense.
I was gonna say there's a lot of folks here. I pretty much took up the entire time, so
Oh no, it's an important topic. I do see that Eric is here, so I don't know how long you've been on, and if you've followed the discussion, but I'd be curious if you had any thoughts.
I joined about 15 minutes ago. I'm still the thoughts I've been listening to of I wonder how much are we regretting that we lost CubeSand, because CubeSand could do small volumes with shared RWX.
Yep.
But I am not coming up with any bright ideas other than what you've already suggested of what sort of workarounds can we do to express the metadata in a way that we can access without using large volumes.
Yep.
But it's an interesting thought. I can certainly, I don't know if QEMU has more that we need to do to make QCOW2 easier to use in small volumes. But it sounds like it's the issue with PVCs that.
Yeah. Yeah, I mean, this is brought upon by the platform itself that makes it a little bit clunky in terms of using the storage. So like, I don't know if I guess for me, with the thoughts that I think that you would have the most expertise on would be Michael's idea of taking a single volume and segmenting it, so that part of it is useful for VM state and another part is useful for is a disk, like a separate item. Like I think libvirt allows you to do start and like an offset and length parameter to a block device. You could technically, like, if you had you wanted space for a 50 gig disk, you could make a 51 gig PVC or something like that, and you could use the first gig as one logical device, and then the second, and then from gig 1 through the end of the device is actually where the storage is. I don't know if that's
yes, libvirt and QEMU do expose the ability to lay on overlays that view a subset of a larger image. As long as the storage itself doesn't have any sharing problems, it may add a little bit of overhead because you're no longer directly accessing the block device, but going through a translation layer of software for every access. But
okay.
But that's, I mean, translation layers and software are still faster than hitting the actual hardware. So that's how LVM does things. So
right. Yeah, exactly. Yeah, no, it's not lost on me what you're saying with that. And then I guess the only issue there though is the kinds of data that we're storing in the VM state PVC. It's not just like one TPM image, because I think you guys gave us block support for TPM, but we also want to put the QCOW2 CBT bitmaps there. So it really would probably be better if it was a file system, and that would be weird to have like a file system on part of the block device and then treat the rest of the device as a raw block device. That would be
not too weird. It's just a matter of how you partition.
Yeah. Yep.
GPT can partition and say, use this partition as a file system, use this partition raw. It's not.
Yeah, that's true.
Not unheard of.
Yeah. Okay. And then the only issue, I think the other issue with that was though, if it was a read, even if it was a read write many block device, when you put a file system on it, it doesn't become like, I'm just trying to think as it gets attached to multiple nodes for a live migration. How do I know QEMU wouldn't be dumb about how it writes, but it's a file system and it has to be mounted by the host. And that if it's, as soon as it's mounted twice, then boom. So
read write many file systems are much harder than read write many blocks.
Yes. Yep.
Much harder.
Yeah. Okay. Yeah, so that's pretty difficult. I think we should still look into that somehow. Like, even if we could, the problem is even if we partitioned the device into multiple partitions so that we could have one one VM state area, and then one overlay, QCOW2 overlay per VM disk. Like you can add disks later, and you can't really manipulate the partition table very dynamically. So, and that becomes really complicated, us managing those device partition tables, which we may not want to get into. So that's, I think, the biggest issue with Michael's idea. I think the potential copia idea is interesting as well, but also not without its own complications.
Correct me if I'm wrong, but with any CSI driver idea means minimal touch points with KubeVirt. It's more on the like deployment opinionating side. KubeVirt already exposes you a
Yep.
VM state storage class, so
Yep.
that's a plus in my eyes.
Yeah, and I think that's an interesting thing to prototype, because yeah, if we bury the copia, basically the volume contents has to be recreated on every attach, and it has to be stored on every detach. But if you have a driver that hides that, it simplifies things. And then basically, if it's easy to, I guess that actually makes the PVC provisioning for vert handlers pretty easy, because you can, like if you lose the data, it's in copia, as long as you didn't lose it while there's a workload that's running. Like you can just provision a fresh PVC, and when you start running VMs on that node, the driver will ensure that when overlay PVCs get created on top of that data, they get populated with what's expected to be there. Yeah, it's an interesting idea.
There's something more that's unrelated to the improvements we had in mind, but it's like it came up in the object graph discussion last week. There's the how we reflect the state of having a PVC, a backend PVC and a VM. Today, it's you need to know KubeVirt to know this. The object graph will help, but even Vladik was saying, like, why is it not in the VM? Why is
Right.
it not? And maybe it's good to just tackle that if we're already in this area. Just
Yep.
tackle
No,
that.
no, I totally agree with that. It's a weird abomination that we tried to hide this from users. Like I think that was a mistake. I agree. So like I think that if you have VM state, then yeah, you should have a VM state PVC. But yeah, I mean, essentially this idea, the copia idea, means that we ship a CSI driver that's an overlay driver, and we create a storage class for it. And then when VMs are newly provisioned, we provision a new PVC within that storage class for the VM. And then that driver provisions that out of, like, by, yeah, essentially initializing a copia something. And then basically vert handlers have to have a PVC per vert handler that is on some sort, probably on the vert default storage class or something like that, and they have to be big enough.
Why?
Because you
We
need a
just
place
use-
to.
We use the same mechanism. Well, bird handler doesn't need to know about any of this. It just does what it does now, and the CSI driver manages the one volume per node.
Okay. So like a daemon set sort of
Yeah,
thing,
and basically
potentially.
what HPP does right now. You can have HPP do that. So we can
Okay.
copy the code.
Okay, and then yeah, basically that storage is persistent, and the CSI driver can know where provisioned copies of the data are currently, and it knows about the Copia repository, and so it knows if it has the data on the PVC. Yeah, but yeah, okay, that makes sense.
Yeah, no, so just doing the attach and the detach. In the detach, you just take it out and you attach, you copy it from the, or, you know, in the detach, you make sure that it's fully synced to the Copia repository, and in the attach, on another node, you just copy it from the Copia repository back.
Yep. Yep. And then for snapshots, you would, I think one thing we would need for snapshots is we'd need a sync call down to the to the VM to make sure that it's flushing all the VM state data out if that's needed, so that we can actually grab a copy of the data.
If you couple this driver to KubeVirt, then you can do all this kind of things in the driver itself. That'd be
Yep.
so cool.
Yeah, and this is like it's a KubeVirt specific driver. It would be automatically deployed by KubeVirt. Yeah, I think that, to me, that sounds like it's actually solving the issues in a pretty elegant way, and it hides the complexity all within the CSI driver, which is kind of the design of how you're supposed to do these kind of things. So I really like that. And we'd probably make a net new one because it'd be something that we're supporting. It's not general purpose volumes that it's supported for. It's only for internal use by KubeVirt. Cool. So it sounds like we almost have something that we could we're almost equipped to maybe even start working on a proof of concept for something like that to see what we run into.
I think we should have like a bake-off between the one PVC, one disk slot and the driver slot.
Mm-hmm.
So I think both of them are interesting and both solve the problem in a different way. And both have their own complexities.
Mm-hmm.
Like Adi pointed out, what happens if the Copia repository goes down?
Yep. Yeah, that would be bad. Okay. So, Alex, did you get what you wanted to out of that conversation?
Yeah.
I have a
Excellent.
question. What are we going to do with the existing VMs with the TPM PVC?
Yeah, that would be a good question. Like, I think you could, I mean, at some point, like new KubeVirts could, essentially migrate to this by like when you launch a new VM that has a dedicated VM state PVC, it could actually create the new data in Copia and provision it that way. And then we just start using that, and then we could have subsequently, like, you don't need the old VM state PVC anymore, so it gets deprovisioned by KubeVirt once we're on the new stuff. I think you could probably automate that.
Yeah, we would have to go back to that KubeVirt dev thread. It was around the same topic. How and when do you live migrate this PVC, this TPM PVC? This was around the semantics, but I believe we never really decided where to go in that direction. Like it's not happening, and we don't know how the semantics are going to be like. So either you, on the KubeVirt level, you declare move them to a different storage, or if we introduce the per VM backend state reflected in the VM spec, then you just treat it as a regular storage live migration. So for existing, I thought it would just, you already have a PVC, like it's inefficient, and if you want to move, you're in the you're in the use case bucket of storage live migration. Just edit the spec and you can move it to the new architecture, to a new storage driver. And that storage driver happens to be that Copia repo one. So for existing, I would say like you carry over that PVC. We don't act on it. We just have to figure out as part of this work what we do with how do we do storage live migration, when, and of course that it works properly for these type of volumes.
Yep.
And it
Yeah.
will mean that for several versions, we will need to support both TPM PVC and per VMs.
It's going to continue to be a PVC if we go that Copia direction. It's just PVC from a different storage class, that's all. So if you want to move to the new architecture, you can storage live migrate. Other than that,
Yeah, but eventually we would want to get rid of the probably the old architecture one, or maybe we wouldn't care that much, but like eventually we wouldn't want to have to test the old architecture anymore. So we'd want to make sure that people are off that.
Yes, but we only can stop testing it when we declare, when we announce that it's deprecated, and we say we remove it.
So with the Copia version, there is no other architecture. It's just still a PVC per VM. It's just that the PVC exists on a different storage class that manages it better than all the other CSI drivers. So there's no different architecture. It's just a different storage class.
anyways,
Other than that, it's exactly the same. So.
This definitely needs to be like addressed in the design. But yeah, that's consistent with my understanding, what Alexander just said. I'm gonna edit here.
Okay. All right, and we have run out of time. Is there anything, like, you have this other small item about a Bazel issue?
Yeah, quickly about that. I think KubeVirt is in a worse case because they depend on the DNF stuff, the Bazel DNF stuff. But for CDI, I would really like to get some time to bump to 124. It's just going to be slightly harder because of Bazel. So the context is in that PR. If anybody wants to take it, that's even better. But staying on an old Golang is just so much stuff is going to accumulate. So if we can take it out of the way soon, that's so much better.
What's the relative complexity of that PR? Does it need somebody that's super experienced and nuanced, or is it something that
yeah, you'd have to go into Bazel, but the KubeVirt PR has references, so some stuff is deprecated and you have to switch and
okay. We should be considering, again, I think it comes up perennially that how can we get off of Bazel?
Yeah, it's one of the worst ones. Like I don't know if I'm the only one bringing it up. I imagine not. I imagine the KubeVirt CI folks are all over this. It's bad this time. Like it's just showing how coupled we are to these Bazel DNF and other. I don't know. I don't even know how you call them. Like, and I'm maintaining CDI, and I don't know the Bazel term for these, like supplementary actions or whatever.
Yep.
So it just goes to show we have no domain knowledge in Bazel, and it's so dangerous.
Yep. Okay.
Yeah, it might be
all right.
So get rid of Bazel for real this time.
Yep. All right, so I'm going to stop sharing, and I think we should wrap up here just because we have gone over time. So thanks everyone for joining. It was a great conversation today. I really appreciate you all being here.
Thank you. Bye bye.
Okay,
Bye-bye.
bye.
Thanks. Bye bye.